There's another phenomenon that is easy to see the results of in many meteorites, but it doesn't form a significant part of the classification, because we find meteorites of this type in achondrites, in chondrites, and even in one type of stony iron. Well, what we're looking at is the result of an impact in space. Now, on this large asteroid, taken from an unmanned pictures from an unmanned spacecraft, it's 69 kilometers in length, as you see it there, asteroid Ida, and you can see that it's pockmarked with all these several kilometer wide craters. These are the result from being impacted like this. Now, the impactors would have to have been smaller compared with Ida than this impactor is, but you get the idea. An impactor can pretty much vaporize itself and vaporize a considerable amount of the larger object that it hits. But if there's a considerable difference in the size, then the smaller one will leave these nice pockmarked craters. Ida itself was probably blasted off an even larger asteroid earlier on. Most of the asteroids are just fragments of bigger objects that used to be up in our solar system that we call the asteroids. Here's a smaller asteroid, only half a kilometer long. And this is some pictures taken by the Japanese Space Agency from one of the unmanned spacecraft they sent up. And notice that the surface of that is a rubble pile with a bunch of blocks coating the surface of it that are the size of houses and small buildings, many of them. Then in that little rectangle there, a detailed picture, now we're looking at a rubble pile of stuff where just big boulders on down to material, some of which must be about the size of grains of sand, all broken up by the surface of this asteroid, getting rubbleized by impacts, not big enough to make significant craters, but big enough to leave all this debris behind. And then part of the asteroid has a smooth surface there, and that might be some original surface, uncertain at this stage. Now, what will happen if something like this part of an asteroid were hit by another asteroid, maybe the same size or a little bit smaller? Well, some of this debris is loose at the surface, some of it at depth will be compacted, and that compacted, broken up material can itself become a little asteroid, which may become a meteoroid and end up on Earth as meteorites. And those meteorites will look something like this. They'll be made up of discernible fragments. This particular one has got these light-colored chondrite fragments. It has, you can hardly point to them, these black bits are a bit of achondrite material. So it looks like an achondrite asteroid and a chondrite asteroid crashed into each other. And we have some biggish bits of the chondrite meteorite, and then a whole bunch of fine silt to sand sized compacted material that's a mixture of the two, and then a few of the slightly larger black bits left behind to look at. The next one down here is a bit of achondrite from the lunar regolith. Some of the white stuff here is some of the highlands rocks that contains a white-colored mineral in it, plagioclase. And then the rest of it is a mixture of other lunar rocks, some of the lunar basalt forming the black stuff, and getting it all mixed together with the white stuff to make the matrix. Vesta, here's some more meteorite fragments. We saw a piece before that was fairly homogeneous. It's an achondrite. Here we see another piece of bill lily. Keep wanting to say bill. It's bill lily. Achondrite, dark gray. Then a mixture of that with this more tanny stuff. It's another fragment up here. Boundaries are harder to see because it's closer in color to the admixture between the two that makes up the bulk of the rest of that specimen. Another piece of bill lily looks like this. And that too is a meteorite breccia. That coarse stuff up in the far corner there is a fragment. You can see its boundary here with this finer grained stuff. And then it's hard to pick out boundaries between some of these other coarse grained fragments and the finer admixture of stuff. So in some cases, the mixture of fragments are all from the same body, but different parts of that body, as is the case with the lunar one. Possibly that's the case with Vesta as well, but in the case of this other one, they're from totally different asteroids. Then there's another type that we'll talk about in more detail in a little bit, but this is a chunk of gray achondrite, no chondrules in it. You see other smaller gray bits like it, and then the silvery stuff is metallic iron. This is one of the stony iron meteorites, a variety that we call a mesosiderite. Siderite is an old word for iron. So we can see a mesosiderite means sort of a mixture of iron and stone. And what would have had to have happened here is that an iron asteroid and an achondrite asteroid collided, and bits and pieces of both fragments of them mixed and then got compacted, and then that stuff got hit again by another asteroid and turned the earlier mixture into what became a meteorite on Earth.